Hi, my name is Wayne Prendos. I'm the recording secretary of the local IS&T chapter. And when I first met Roger, it was after 7 years of leaving undergrad, walking into a room to my very first class at RIT, calculus of complex variables. And I was in absolute panic and realized I had no business being here. Calculus of complex variables. And I was in absolute panic and realized I had no business being here. Eventually, I worked all that. Roger was on my my committee for my master's thesis, and so I learned a lot of math, and he learned a little MRI, and we became good friends. The poor guy suffered for 50 miles in the back of my tandem. If that's not friendship, what is? And so while I was working MRI stuff, Roger transitioned into this idea of archiving ancient documents and photographing and finding the secrets within. And since he's well-known and since this is a well-known piece of his work, I'm going to let him get right to the subject here. But we're very excited to enjoy the teaching of Dr. Easton.
Well,
thank you, Roger.
Thank you. Yeah, and I want to make sure I introduce Izzy Moyer, who's here with our new system, the new inexpensive system. So I'm going to talk a little bit at the beginning about the history of imaging of cultural heritage, and then say a little bit about two of our kind of recent projects. So, but this is sort of a history and the modern application of imaging, and this is a continuation of work that was done by Bob Johnston, who had been the Dean of the College of Fine Arts, passed away in 2005. There he is with the system that he had, and there's the Kodak DCS 100, which was, if I remember right, 1.25 megapixels. That was, and it cost $25,000. So that was the camera that we got started in this, sort of in the mid-90s. And Bob was particularly interested in trying to look inside cuneiform tablets. You know, the outside of the tablet is sort of the envelope, and then the message is inside. So he wanted to be able to read that. So we tried doing some X-ray stuff for that, and then some image processing. All this kind of grew out of that. And then the second inspiration for this is Will Knoll, who literally was hit by a truck in Edinburgh in April and passed away. And he was sort of the inspiration behind the work with the Archimedes palimpsest, the oldest known copy of the writings of Archimedes that we worked on. And Kevin Bleckel, sitting back there, made one of the big discoveries on that. I'm not going to talk about that project. I'll probably mention it in passing, but that was sort of where we really cut our teeth on this, where we really learned how to do it, thanks in large part to some of the observations that Kevin made. And Will was also the owner interface. The owner of the Archimedes is an interesting guy, and Will was the interface between us and him. I was we were imaging in Cambridge University Library in 2018, and I remember saying to Keith Knox, we're sitting in the tea room having lunch. Wouldn't it be funny if Will Knoll walked in? The next day he did. That was cool. So anyway, and then lots of other acknowledgments. Izzy, I mentioned Kevin, but I didn't list him on here because I wasn't planning to talk about the Archimedes. But quite a few other people. Damianos Kazatakis is the guy who does the imaging for us at St. Catherine's Monastery in Sinai. And he and I are good buddies. He lives in Vienna right now, so he's in the rain. So there are a lot of technologies that are applicable to cultural heritage studies and, stuff for material science. But of course, I'm going to focus just primarily on, almost exclusively on the multispectral imaging. But we've done a lot of these other ones as well, including X-ray fluorescence. And we've got some useful results out of those. But the focus of this is multispectral. And so this audience is probably well acquainted with that. It's just imaging under a variety of wavelengths, typically including bands of light the eye can't see. And then we post-process that data to try to find a combination of those images that enhances the visibility of whatever it is we're looking for. And most often that's erased text in a palimpsest. And now for this audience, maybe this would be useful. A palimpsest comes from, it's a compound word from ancient Greek, the two roots meaning scraped and again. And so it was literally you scrape the writing off parchment and then rewrite over it, because parchment, animal skin, was expensive to make, except when you're in England, where apparently there are no palimpsests because they had so many sheep. But certainly in the Mideast, there were lots of palimpsests in St. Catherine's Monastery in Sinai. There are a couple hundred, of which we've imaged 75, and we hope to image the rest. So this is a photograph taken by Agnes Smith Lewis in the 1890s. She and her twin sister, Margaret, were the Sisters of Sinai. And if you've got any interest in the subject, there's a great book about them that I just happened upon 2 weeks before I was headed to Sinai the first time. So there you can see the writing. Oftentimes you see show through here, but this is actually the erased writing from the same side. The history of multispectral imaging for cultural heritage is not new. And that's one of the great things I found out in the course of learning about this stuff. And I just found some more references just within the last couple of hours. So this was everybody in this audience probably has heard of William Henry Fox Talbot. He actually proposed using imaging with wavelengths that we can't see back in 1844. But the idea of combining the images was implemented in Germany by Pringsheim and Gradenwitz in the 1890s. And then it was modified roughly 10 years later by this Benedictine monk, Raphael Kurgel, who was an interesting character too. And I'll mention a little bit about him. And then the subsequent work by many others, but it was all kind of constrained by the fact that it was photography. And in Rochester, that might be heresy to say, but nonetheless, it was true. And then when the digital imaging revolution started in the 1970s, multispectral imaging of cultural heritage kind of restarted. And one of the guys who did that was John Benton at Caltech. And I'll mention him briefly later on. But it was because we got all these new technologies available to us in imaging and computing, in illumination, and also in optics, in the lenses. So here's William Henry Fox Talbot, and this is from his book, which is available online, The Pencil of Nature. It was a book describing how you can use photography to do scientific studies. And he talked about introducing infrared light into a room, and but no visible light, so everybody in there wouldn't be able to see anything. So we separate those invisible rays, fill the room with them. I like this. We must not call the room illuminated because you can't see it. And if there were a number of persons in there, no one would see each other, but a camera could. So you could, the eye of the camera would see plainly where the human eye saw nothing but darkness. So he's sort of a peeping Tom kind of a discussion here. But we would suppose the secrets of the darkened chamber to be revealed by testimony of the printed paper. So I just thought that was kind of cool. And then this idea of photography to document them. Again, Agnes Smith Lewis was one of the interesting people who got this started. And she did some really interesting stuff, considering, number one, she was a woman, and number two, she was in Sinai, where women were not typically present. And both her and her sister did a lot of really interesting stuff. So this is a photograph from one of Agnes's books about discovering the Codex Sinaiticus, how the codex was found. And there's the photograph showing the thumb of the librarian Galaction and one of the monks. And of course, we sort of have parallel pictures now because photographs with Father Justin, the librarian of St. Catherine's now, who's an American from El Paso. Really nice guy. So after that came along the work from Pringsheim Gradenwitz, and Pringsheim, a well-known experimental physicist. He actually invented the infrared spectrometer. He was the guy who made the measurements that were used by Max Planck, talking about quantum theory of light. And then his partner in this project, oops, I hit the mouse. His partner in this project was Otto Gradenwitz, a professor of law. And these guys came up with a method that they combined photographs taken under two different conditions and exposures and emulsions in such a way to enhance the visibility of the text that have been erased. And so maybe show it in stages. So here's one of the two photographs. And in this case, you can see the erased text, the larger text. You can see the smaller dark text. That's the overtext. That's the text that was written later. So here you can see both. Then they took a different image with the same system, but with a different filter and different emulsion, different development. And they got an image that was pretty much just the overtext. And then they took that and they made a negative out of it. And then they borrowed from the Astrophysical Observatory of Potsdam, this guy Hermann Karl Vogel, who's very well known in his own right. He lent them the gadget that allowed them to line the two plates up as close as they could. I would say exactly, but as exactly as they could do it. And then they photographed that. And so there's Vogel, another really accomplished scientist. He's got craters named after him on the moon, on Mars, and there's also an asteroid. I mean, how many named items does he need? He's probably got a star named after him from the star registry too. So here, back that same picture that we started with, the positive and the negative, and then lined the two up and got that. And when I first saw this is a great thing about the internet, because I was able to find this paper pretty quickly once I knew about it. And I'm just sitting there going, God, I wish we could do it that well. So that was a terrific result where you can enhance the visibility of the undertext. I don't know what the page is. I mean, I went back and looked up their papers, and they gave no indication what the object was, that they took that out. So subsequent to that, this monk that I mentioned, Father Kurgel, added or substituted ultraviolet illumination for one of the two images, which makes the parchment fluoresce and enhances the visibility of the faint text, because the parchment around the text is now glowing. So you get, and yet the remnants of the erased ink still obstructs the ultraviolet, so it doesn't enhance there. So, and then he actually, there's his filter, which was a glass cuvette. He could put liquid in there. So again, just have an awful lot of respect for the lab experience that these people had. And they had to make their own ultraviolet. And Kurgel had a very interesting, I'll show that. I thought it was this one, but well, let me just jump ahead to the next one. Here's his ultraviolet illuminator. He got a German patent. That was the other thing. Once I realized that DRP was the German patent office, within 30 seconds, I had the patent on my desktop, because every patent is available by number. And so that was pretty cool. So what he did was he brought the light in, and then he had quartz prisms, and of course the prisms would refract the short wavelengths the most. And so he got from the upper prism, he got ultraviolet at the bottom. From the lower prism, he got ultraviolet at the top. So he got, a range of ultraviolet exposure across the object. He didn't have ultraviolet fluorescent lamps like we do now. So I thought that was pretty cool too. And then he did a lot of studies of this, published a lot of papers, including this 120-page monograph in 1920 on palimpsest photography that's available, of course, is available online. And I went through, and thanks to that availability in Google Translate, I've got a translated copy of it now. I already mentioned the liquid filters, but here's the discussion from that book, what he did. I mean, he actually eventually had to make them out of optical glass so that it didn't disrupt the image quality. So that led to this, and here's the book right here. So I invite you to come up and take a look at it afterwards. They published this book in 1913 of palimpsest pages that were enhanced photographically. So they did all the leaves of this palimpsest, published it within like a year, which kind of shames us compared to how long it takes us to do processing for some of the things we do. And you look at the end there, it specifically says volume 1. This was intended to be the first volume in a series, but it was published in Germany in Leipzig in 1913. Obviously, they never published another copy, another book. This was the only one they did. And this came up for sale, 10 years ago maybe. And Steve was kind enough to buy it at my suggestion for the collection. So from that, here is the photograph scanned in, the approximate visual appearance, and the result after the image processing to enhance the visibility of the erased text. Given what the equipment they had to work with, the results just spectacular. So then I was working away I remember one Saturday night, and I came across this at the back of an article talking about this manuscript, and did the Google translation. They actually had a business. They said, you bring us your palimpsest and we'll give you the images of the result without having to paint chemical reagent on it. And, for 350 marks at 9 by 12 centimeters and 5.5 marks at a larger size. And, that's pretty reasonable, I would say. So I just found that was fascinating too. But then Kurgel, as I mentioned, he was an interesting character. He resigned from the Benedictines, 1924. He returned to his birth name of Gustav, got married, had a daughter and son. I obviously had a typo there. I was putting the slide together a couple hours ago. And then at the same time, he systematically disposed of his past. Why did he do that? Because he became a Nazi. And he raised the Hitler flag the day after the election. And as a result of that, after the war, he thought the denazification court was going to classify him in the group of main culprits, so he hung himself. He committed suicide. So just an interesting little sidebar to this. So again, now we have seen what we can do with manuscripts. The situation remained kind of static until the technology changed. And this guy was part of the reason for that, John Benton, who was a professor endowed chair professor of history at Caltech. He and I both went to the same undergrad school, 19 years apart. But he started to use technology borrowed from JPL to do imaging of manuscripts and specifically palimpsests using Vidicons and digital image processing. And as a result of that, he was elected a MacArthur Fellow. But unfortunately, 3 years later, he died in an accident. And so he never got to finish his MacArthur work. He was only 56. So he used a Vidicon because it was the best they had, but I like this. May well be significant advantages, again, typed it in quickly, using a CCD or a solid state line array camera. So we're talking back in 1978, what he had available. And then, of course, they had to write it to mag tape, and they had 8-bit quantization. And so there was a significant limit. I think I'll just skip this. This was stuff I was starting to put together for a subsequent talk I'm going to give in Glasgow. But so just some examples of, the object and the histogram, and then just doing simple digital image processing back in 1978, and to recover the writing from, got a MacArthur for that, which is kind of cool. Okay, so there's sort of the history of how this stuff got started. And now the technology's advanced again, the prices have come down, the capability's gone up, but there's an obvious need to apply this. And Greg Hayworth, colleague up now at the U of R, did a estimate saying he figures that there are at least 60,000 manuscripts just in Europe that could benefit from this. And there are many obvious other places that could benefit as well. And so that sort of led us to this. So how to attack the problem? Well, one way is we're going to spread the gospel of imaging to the masses of the manuscript scholars. And we're already doing that. So there's too much work to do for a small number of technical groups with a high capability. We need people to get out there and find out where the objects are that need to be imaged. And so that's why we came up with this. I say we, a survey instrument. I think of this as a survey instrument. So it's an inexpensive system. And we have our own free image processing tools and also the image collecting tools. And we sort of need to establish a new kind of paradigm in manuscript studies where objects no longer become, finger quotes, owned by the people who are studying them, as was the case back with the Dead Sea Scrolls in the 40s. People sort of had ownership of the object, and if they didn't want to publish it, it didn't get published. So this is sort of the range of cameras that we've used over the last 20 plus years. Goes back to the DCS 100, which I mentioned the picture with Bob Johnston. And we had a Nikon quartz lens to be able to get the high quality images. $25,000 got a photometric census, which was 1.5 megapixel. I still have the camera. And then, but the one we used on the Archimedes was the DCS 760, the first sort of Kodak professional grade for photojournalists, RGB camera, which had some benefits, but probably would have been nicer to have a monochromatic. And then just skip the rest until we get to we still use the Kodak 50 megapixel sensor for some of our stuff, but we're sort of transitioning to the Sony CMOS 150 megapixel, but 150 is too many. The pixels are too small, particularly when you're imaging fluorescence. You get too much noise. So we actually bin it 2 by 2 when we do that. So here's the situation in our current big system, the one where we do most of our high quality work. So 19 bands in reflection, 4 bands for fluorescence through different filters. So for the UV illumination, we'll have 6 filters. For the visible light illumination, we'll skip the UV pass and the UV block, so we'll only have 4. And then we also have 4 bands in transmission, and they're all tilted towards the long wavelength then, because that's where you get the best signal through the object. But one of the things that this audience is probably not necessary, but to some of our former colleagues, now competitors, they think that you can do it with just a regular old camera lens. And so this is the camera lens that we first started to use, the Micro Nikkor 60 millimeter. And of course, it's corrected at 3 wavelengths, but they're all visible. And so here's a leaf of the Archimedes palimpsest at 365 through that lens at 570, at 625, and now at 870, and it's out of focus. And we have colleagues who say, I don't care. Well, I think they're wrong. So why does it go out of focus? Because it's only corrected in the visible. And as you go out to the infrared, you know, there's where the sensor location, the thick black line's where the sensor is, and the other line is where the image is, with a focus shift. So the image goes way out of focus, the sensor. And again, to this audience, that's probably totally obvious. So possible strategies, you can refocus the lens, and there are people who do this. The camera at the Vatican, that's what they do. And I've got data from it, and you can't do anything with it because the image scale changes as you refocus it. The more expensive fix, but the better one, is to redesign the lens. And so here is the 35 millimeter version of this, which I bought with I didn't pay myself with on the Archimedes project. I bought this lens. And it's corrected again at 3 wavelengths, but now only one of them is in the visible. And so this is designed to be used at ultraviolet, visible, and infrared. So here is the chromatic aberration curve showing the amount of defocus at the different wavelengths out into the infrared. And then here are the corresponding images, different part of the Archimedes, but still 365, 570, 735, and now 940. So we're farther out into the infrared and the image is still sharp. So that's what we wanted to use. And of course, when we went to the large format sensor, that lens was almost good enough. It just not quite good enough at the edges. So Ken Boydston at Megavision had Brian Caldwell, who designed the UV Vis IR lens for coastal optics that then got sold to Gina. He designed a larger format version, and that's the one that we use in our system now. Okay, as a result of that, I thought maybe you'd be interested in just seeing a couple of results from a couple of projects, and then we'll talk about the survey system. And these were turned out to be kind of connected both to each other and to the Archimedes. So 2 different manuscripts, what we call CCR, Codex Clamaci Rescriptus, which had been at St. Catherine's Monastery and got borrowed, stolen. And in fact, Agnes Smith Lewis bought a quire of it in their collection. And but it exists other places too. And then this also this second manuscript, L99 Soup. The shelf mark doesn't really mean much to us, but it's at the Ambrosiana Library in Milan. Both manuscripts had unidentified erased text, and in the course of the projects, they've been identified, and they're both important in the history of astronomy, which goes along with Steve's new acquisition here of the Copernicus. So here is the CCR, 9 or more erased undertext in a bunch of different languages, recycled in a Syriac translation of the writings of John Climacus, who had been the abbot at St. Catherine's Monastery in Sinai, where we've done a lot of other imaging. And John Climacus is famous for this image of the ladder of divine ascent, which has worked its way into some movies at various points in time. But the original manuscript, as I said, fragmented into widely scattered folios, including one that Agnes bought, and folios from Berlin that she collected, and then photos that were acquired in Port Suez. And then once the Smith sisters had them collected, they donated them to Westminster College in Cambridge. And the college eventually decided, well, we need some money, so let's sell it. And so they had an unsuccessful auction in 2010, but then Steve Green of the Green family, the owners of Hobby Lobby, bought the book from Westminster College and donated it to his museum, the Museum of the Bible, in 2012. And that's where we came across it. So there is one of the leaves of it, just showing what it looks like. So we imaged that in 2017 in Oklahoma City. The headquarters of Hobby Lobby and the headquarters of the museum are both next to each other in Oklahoma City. And so we went there and imaged it, and that at that time we had the 50 megapixel CCD sensor, and then the next year we were at Tyndale House in Cambridge, and it was the same week that Harry and Meghan got married, and we had a bunch of people who worked on the imaging, also worked on the processing, and then we had the scholars right there with us. And boy, that's really helpful. You know, they can look at an image and say, show me, work on that spot. I can read this, work on that. And so I was sitting there working on folio 48 verso. And so there is a section of that. And suddenly, you know, did a process and came up with that. And say, so my first thought, why should I see concentric circles in this? And so the images that we processed, Peter Williams, who's the principal and the CEO of Tyndale House, which is this very famous religious studies place in Cambridge, he noticed some odd numbers in the text, so he contacted Victor Geisenberg of the CNRS, the Centre National de Recherche de Sciences, the Center for the Sciences in Scientific Research in Paris. And between the two of them, they decided they were star coordinates. And so those concentric circles are the symbol for the Corona Borealis. And so there are Peter, and I found this picture on the... So Victor and Emmanuel, we work with a lot now. We have regular meetings with them on Zoom. And so I found that great picture of the two of them. So here's the, again, visual appearance. Here's a processed image. And then here is Emmanuel's tracing from that. Obviously, he knows the language. He's able to, he can pretty readily fill in the spots that we have difficulty giving to him. But turned out this was the star catalog by Hipparchus. So Greek astronomer, known to have been working on a star catalog in, you know, between 160 and 120 BC. And turned out, and they knew that this catalog had existed, but no copies exist anymore until this was found. And so I love this. Victor and Peter and Emmanuel knew the star coordinates, and they worked backwards from the star coordinates now to the star coordinates then, and figured out that the precession of the Earth, from the precession of the Earth, they figured out when the catalog was made, and at 129 BC. So it's exactly when it was supposed to. So this was really cool. I mean, and then, you know, they actually came up with a translation, probably more than, we probably don't need to read it here, but they were able to get significant amounts of the information from it. We have many more images, work still to be done. And they have a nice online publication, 2022, about that. So as a result of that, that kind of led in sort of intricate way through Victor and Emmanuel to this other manuscript by Ptolemy. So Hipparchus is, again, was star catalog, known to exist, no copies. The oldest other catalog known to exist was by Ptolemy. And so he was, you know, a couple hundred years later, and he also designed astronomical instruments. And so this manuscript in Milan, palimpsested, had been imaged by a couple of other guys, and this was what they have discovered is in that thing. There's a discussion of on the analemma by Ptolemy, and a previous unidentified and unread text, 6 leaves, and now, as a result of those images, they realized it was a different instrument called the meteoroscope, and that manuscript was treated with reagent to help try to read the palimpsested writings back in the 1800s. And this guy, Cardinal Angelo Maia, is famous for doing that. He's we curse him because he makes it much harder to read the images because of the brown stains left. And again, the scholars, Victor and Emmanuel, but now Alexander Jones, not Alex Jones, who worked on the Archimedes with us back, 25 years ago. So he's interested in this. He's at NYU. And there you see the damage from the reagent that Angelo Maya painted on them in the 1800s. So that's what we have to work with. So as a result of that, we've gone back to work on the images of this particular one, which is not the Ptolemy. This is a different one, but we going back to try to recover text from the areas damaged by reagent. We've been back there 4 times in 2 years. And there's more work to be done. So, turns out this same manuscript was studied by this guy, Johann Ludwig Heiberg, in 1895, and he was a key player in the Archimedes palimpsest. He was the guy who he studied the Archimedes palimpsest, identified what the source was back in 1906. And he also identified on the analemma in this one. And so just interesting that all these different characters come together in some of these studies. So he had several leaves of the Archimedes photograph. Again, the fact that he had photographed them was known. They didn't know where they were. Will Knoll, the guy who I mentioned early on, who has since died in a traffic accident, he was the guy who went to the Royal Library in Copenhagen and found them. So back in 2002, somewhere around there. So we had images that had been taken by another team, and then Keith Knox, a colleague of several of you know, did some reprocessing of those, and then we went back and did some re-imaging as a result in 2022. And so here's some results from that. So again, you see the reagent damage, and there is a processed image using spectral angle mapping, which is one of the techniques that we often use. So you get some improvement in the visibility of the undertext, and then a pseudocolor of principal component. And Emmanuel will just look at that and just read it. I mean, he's spectacularly capable of that. And as a result of that study, they were able to make a 3D printing model of the meteoroscope. So that was kind of cool. And another online publication. Okay, so now, got a few more minutes, transition to, so you've seen something about how the big system works and what we can do with it. But the big system is expensive and hard to haul around, and there are only a few of them in the world. So we need, and there are many manuscripts that need work. So we need the capability to sort of have more people work on them to do studies. And so this is the MISHA system. And Kevin Sacca's, one of his roommates was named MISHA. So he worked up an acronym to fit his roommate's name. And it was his senior project in 2016. And that led to a grad student who became a staff member, Tanya Kleinens, who has presented about that to you guys 3 or 4 years. It was pre-COVID. So I'm guessing it was December of 19. So that was they did a grant proposal to NEH and got $350K in funding for a 3-year project. And to build these things, I think of them as a survey instrument. Some of my colleagues are trying to say, you're trying to sell this as the big thing. No, we're not. We just want people to have access to a system that they can go and find out what's useful to look at. So this thing with the small sensor and the wide field of view, we can only get about 400 dpi for a typical sized object, but it doesn't meet the imaging standard of 600 dpi. But I don't think it's supposed to. To me, that's not what it was intended to do, and it's still a useful gadget. So, and the capabilities are pretty comparable to what we had the last time we imaged the Archimedes in 2007. Those images have some flaws. We'd like to go back to the owner to re-image a few of the leaves, but it still gave us really useful results. So this has significantly less capability. There's no fluorescence, there's no transmission, there's only reflection, and there are 16 bands of that, which is more than we have on the Archimedes, but gives us some useful results. These have been used in a variety of locations. There you see Izzy in Dubrovnik, where she's going to be 2 weeks from now for 9 months, using this system at the National Archives of Croatia. Buff State, Case Western Reserve, Washington University, St. Louis. These are only a few. There have been other places as well. This thing has a fairly broad response. We have a UV Vis IR lens. We have a Vis IR lens in it. There's the lens. That's the most expensive component in the whole system. The goal was to build this thing for about $7,000. The lens is about $2,000. So, but you know, you put the money where it's most important. It has its own software. The image collection, I would say, is probably the more difficult of the two, because you need to be able to interface to the different possible cameras that people can use. But and you've got to be able to run it on your computer. So we suggest specific computers for people to get. The processing software has to be able to run on Windows or iOS. And it's pretty basic, but also it's free. So we can do a variety of things. And that's the example, the leaf that Steve pulled out for us right here, that's palimpsested. And so there's some results showing the palimpsested writing underneath the music score on that leaf. Izzy may have some additions that we can make on this. We know we have systems placed. Helen Davies was a longtime colleague. I worked with her since she was at University of Mississippi and then at University of Rochester. She's at University of Colorado, Colorado Springs, and she has one, and she's taken it to Europe several times. One time she came back, but it didn't. Lufthansa still has it. They don't know where it is. But Bill Enders at University of Oklahoma, I mentioned earlier this Voynich that we had an announcement about just in the last week. He gave significant help on that, but he's done he's working on a manuscript in Hereford in England and imaged the whole thing with one of these systems and figured out what pages needed to be worked on. Tom Rieger, who's an RIT alum, just about to retire at the Library of Congress. He's building a system there. I mentioned Victor Geisenberg. He's building a system for the CNRS in Paris. I mentioned Croatia. University of Toronto just borrowed a system last week, and they're building their own. University of Sao Paulo in Brazil is building one. I didn't put up here Colombia, Bogota, National Library in Colombia, in Bogota. They're going to come up, pick up a system and take it back. And plus we have several others that people are building. The instructions are online. The software is available for free. So hopefully people are going to be able to do this themselves. And we've also lent them out to Washington University, the Ransom Center at Texas. Toronto has one right now, and Case Western Reserve. And that's it.
Would there be interest in building a camera system that worked from UV, let's say, all the way up to long wavelength 20?
Absolutely. Yeah.
Okay.
I mean, multiple sensors. Where did we just hear somebody's done that? They've got a camera with 2 sensors in it, and they can go out to, I'm going to, make up a number, but it was something like 1.5 or 1.8.
I thought it was Megavision or something.
I don't think it's Megavision.
But
anyway, the short answer to your question is, yeah, we would like to be able to do that, but part of the issue is the modalities. I mean, you know, illuminate with UV and image the color of the glow, which was what Kevin discovered for us. I mean, he made that discovery on the Archimedes, and it completely changed the way we collect data. So whenever I get angry about all the data we collect, I blame Kevin. No, he got a spectacularly good result on the Archimedes. We couldn't have gotten any other way.
I mean, you have to think about get the light source and the camera together in a black box.
Mm-hmm. Yep.
Running through my head, I think I know it.
Oh, wow. Hey, be happy to talk. And there's a lot of interest growing in this. Anybody who's interested in studying manuscripts anywhere is probably trying to do this now.
Could you talk a little bit about the image processing line?
Could I talk a little bit? Is that
you went really quick by this page that had like 10 algorithms on it. So you've got this 40-something planes of data, and then you mentioned like there was a whole page of stuff you did to come up with a different. How do you extract the individual? You've got text.
How do we do the processing?
Yeah. What are the tricks you use to turn these multiple planes of data into actual products?
Boy, that would take a while. A lot of we might take 40 bands of data, but not all 40 have stuff in them. In fact, that was one of the discoveries when we were working on the reagent damage manuscripts in Verona. We had all the reflective bands, and Keith Knox and I are sitting there together and, okay, I'll try these and you try those. And it turned out we've found that a subset of 2 displaced sets we got the best result of the results we've gotten. The best results came from those. So we did UV and we did infrared, and we combined them, and then we do, PCA or ICA, minimum noise fraction. The example that I showed there, that was a spectral angle map. If you know a particular set of pixels came from the text you're interested in, you can make a map that says, show me all the pixels with that spectrum. And that oftentimes is useful, and that's quick. And a lot of this stuff iterates. You'll do one thing and figure out the text over there, and then as a result of that, you'll figure out text over here with something else. And the scholars have gotten used to that, So I'm not sure that addressed your question, but there's a lot of things we do, and it's mainly just keep trying. I mean, one of my colleagues at the Austrian Academy of Science, she always says, well, can you try something different? Yeah, I suppose. What's that? It's good, just keep, throwing it at the wall and see what sticks. And oftentimes, Emmanuel Zing can read stuff that I can't even see. And so, that another lesson is anytime I get a result, I send it to him.
Very good. Yeah, go ahead.
Yeah. Oh, should I talk on here? Okay. So you kind of alluded to the carloads of data, lots of data. Is there any thought at this point, as this sort of approach catches on, to what gets archived of the record? You were sort of saying not the raw data. And I guess when I saw that limited number of processing techniques, clearly those are the basic one. Is there generally a consensus on approaches given the type? It might be material sensitive.
Yeah, certainly material sensitive. Sure. I mean, we only do have a sort of a limited subset of processing methods. So it often boils down to figuring out which bands you're going to do in that processing. And a lot of that is trial and error. Dave Kelby, who was an undergrad and then a grad student who worked on the data at St. Catherine's, who now works for a company in New Zealand, and he just happens to be back visiting mom this week. He was going to come tonight, except he was tied up with something else. He is very good at you know, looking at the bands, and he often does 3 sets of 3. So he'll do 3 bands here and make a combination, 3 bands here and 3 bands here, make combinations from those, and then makes a pseudo color from those 3. And he just gets result. I mean, how did you do that? And he's very meticulous. He writes everything down and looks very carefully at what's happening, where I'm much more throw it at the wall. See what works.
Yeah, I guess I was thinking of particularly, for example, the move to, say, Library of Congress. Their interest is in archiving and then exchange of information. So I was sort of trying to think about, as you were saying that, what would, for example, be candidate to exchange between interpreters, between scholars. And it's maybe there isn't consensus yet.
Yeah, I certainly don't know of one. And I mean, you know, right now we just store everything. And, you know, including in the processing, you do statistical process. You pick a region where you're going to evaluate the statistics. I save all of that. I mean, so I just get, you know, gobs and gobs of data that, you know, probably if 1% of that data gets looked at again, that's probably a lot. But we still have it.